Imagine, just for a second, holding a single microscopic grain of sand right in the palm of your hand. Now imagine that locked inside that nearly invisible little speck is an 80-year-old mystery. We're talking about a secret that has literally been hiding in plain sight since one of the most consequential days in all of human history. Welcome to this explainer. Today we're taking a journey from the absolute smallest atomic scale all the way up to the massive, earth-shattering forces of the 1945 Hiroshima atomic explosion. We're going to look at a recent scientific discovery that has absolutely stunned material scientists. It's forcing us to totally rethink what happens to ordinary matter under extreme conditions. And you know what? It might just unlock entirely new materials for our future.
Okay, let's dive into this. 12,000 degrees Fahrenheit, or, roughly 7,000 degrees Celsius. It is a number that is just almost impossible for our brains to truly wrap around. I mean, at this temperature, the physical rules that govern our everyday lives, they just stop applying. Steel doesn't just melt, it literally vaporizes. Concrete turns straight into gas, and it's precisely this incomprehensible temperature that it took to forge the scientific secret we're looking at today. For decades, scientists have been wondering what exactly happens to the Earth's basic building blocks when they're subjected to this kind of absolute hellscape. And recently, thanks to modern technology, they finally found an answer hiding right there within the fallout.
Section 1. An 80-year-old mystery. The secrets hidden in the sands of Hiroshima Bay.
To really grasp this macro-level scientific detective story, we have to start at the actual scene where these extreme forces were unleashed. Our story centers around 34 very specific fallout samples collected from the sands of Hiroshima Bay. Researchers call these tiny particles Hiroshimaites. Simply put, these are tiny glass-like spheres and fallout droplets that formed within the very first seconds of the atomic bomb explosion back on August 6, 1945. For nearly 8 decades, these tiny droplets just sat dormant in sample jars. They were silent witnesses to history, basically just waiting for electron microscopes and X-ray diffraction tools to get powerful enough to peer inside their atomic structure. And when a team of researchers finally looked closely at these 34 samples, well, they found something they totally didn't expect.
It brings up this absolutely fascinating question. What actually happens to matter at the extreme edge of physics? We all know how everyday materials behave in an oven, right, or in a standard factory forge, but what happens to ordinary materials when they're subjected to a supernormal environment? Literally the most violent, catastrophic environment ever created by humanity. To answer that, we've got to look closely at the exact sequence of events that created these Hiroshimites in the first place.
Section 2. Inside the nuclear fireball, tracing the timeline of extreme heat and pressure. We're going to trace the exact terrifying timeline that birthed these particles. The bomb dropped on Hiroshima, codenamed Little Boy, weighed about 9,000 pounds. When it detonated, it unleashed physical forces that completely defy logic. So let's track the timeline here. At exactly 0 milliseconds, the bomb detonates with a blast equivalent to 20,000 tons of TNT. Moving forward just a fraction of a blink of an eye to 100 milliseconds, the temperature inside that fireball rapidly exceeds 12,000 degrees Fahrenheit. And by the time a single second has ticked past on the clock, the environment has fundamentally changed. We see the instant vaporization of absolutely everything in the blast radius. Buildings, steel infrastructure, soil, glass, water, all of it turned instantaneously into this swirling cloud of superheated vapor.
And this brilliantly illustrates the exact sequence that forged our mystery material. First, we get that complete vaporization of metallic structures and soil. All of those elements mixed together in a gaseous state. Second, we have the rapid, violent expansion of the nuclear fireball outward. And third, as that fireball expands into the atmosphere, we get an instantaneous cooling of that metallic vapor. Think of it like flash freezing a snapshot of pure chaos. The atoms were bouncing around wildly in this gaseous soup, and then, in just a fraction of a second, they were locked into place, forming solid droplets that rained down as Hiroshimaites.
Section 3. The impossible crystal, a never-before-seen atomic structure. Zooming back in under the high-powered electron microscope, researchers examined the metallic particles locked inside these Hiroshimaites. Using X-ray diffraction, they found an incredibly specific mix of ingredients inside one tiny grain. We've got iron, chromium, nickel, manganese, molybdenum, silicon, and aluminum. Now, if you know anything about metallurgy, you know that these are not exotic materials. There's no rare earth magic happening here at all. These are everyday common elements. The ingredients themselves are completely ordinary, derived directly from the everyday infrastructure of the city that was vaporized.
Now, what's really interesting about this slide is what they expected to find versus what they actually found. In most of the particles tested, researchers fully expected to find standard alloys. And they did.
Things like a common iron-chromium mix, which you'd find in conventional materials all over the world. But in one specific microscopic grain, featuring those 7 elements we just talked about, they found something impossible. A highly ordered, multi-component atomic structure that has literally never before been observed naturally on Earth. It was an entirely new crystal structure, an entirely new metallic alloy born straight out of unimaginable destruction.
I really want to emphasize this point, because it's truly mind-bending. The bomb didn't create new elements. The periodic table didn't suddenly expand that day. Instead, the extreme heat, pressure, and instantaneous cooling of the nuclear fireball forced existing, ordinary elements into an entirely new, highly ordered arrangement. It's kind of like if you took a handful of random Lego bricks, tossed them into a tornado, and they instantly fused together in midair into a complex, perfectly ordered geometric shape that no human had ever even designed. The sheer force of the event dictated a completely new way for atoms to lock together.
Let's move to and see how this builds into Section 4. Forging the future, how catastrophic origins could lead to scientific breakthroughs.
Let's zoom out and look at the broader scientific picture. Why does this one tiny grain of impossible crystal actually matter to us right now? Well, it opens up a massive new frontier for materials science. First off, it helps researchers deeply understand the physics of extreme events, like nuclear explosions or even massive asteroid impacts, by showing us the chemical and physical fallout they produce. But on a much more practical level, studying how these atoms lock together in such a unique, stable way under extreme stress, that could pave the way for humanity to develop ultra-lightweight materials and engineer extreme heat-resistant alloys. We are talking about the exact kind of advanced metals we desperately need to shield spacecraft during violent atmospheric re-entry or to build exploratory probes that can survive getting close to our sun. It's literally giving us the building blocks for deep space travel, next-generation aviation, and planetary defense.
So, the crucial point is beautifully summarized by this thought. Even the worst moments of history can further shape our understanding of the natural world. The 1945 bombing of Hiroshima was an event of devastating destruction and just immense human tragedy. Yet 80 years later, the literal ashes of that catastrophic blast are providing materials scientists with stepping stones. It's a profound reminder, really, that science is this ongoing process of discovery, where even the absolute darkest chapters of our past can yield knowledge that might one day help us engineer a better, safer future.
Which leaves us with this final, thrilling puzzle for the future of materials science. Now that we know this impossible crystal exists, and we know exactly what common elements make it up, the big question is, can we recreate this catastrophic forge in a lab without, the nuclear explosion? Can we figure out how to safely manufacture this strange, highly ordered alloy on demand? Because if we can, it could unlock a whole new era of advanced engineering. But until then, this tiny grain of sand from Hiroshima Bay remains a testament to the awesome, terrifying, and endlessly surprising power of extreme physics. Thanks so much for joining me on this explainer, and remember, keep questioning the world around you.